Welcome to my new calculus channel. My name is John Gabriel. In this video today, I'll discuss once again with you the mean value theorem and how we can actually use it to find areas and volumes and everything else. Okay, so the fundamental theorem of calculus is actually derived in one step from the mean value theorem. I was also the first to prove the mean value theorem constructively. And I'll show you in a moment how this all works together. So let's begin. Right. Now, what you see in front of you here is the graph of f of x in blue and its derivative in red. And actually, what you're doing is you're finding the area under f of x, okay? In order to do this, you need a result from the mean value theorem, which says that this line here is the arithmetic mean of all the vertical line lengths in this region. So let me see if I can draw on this. So let's do this screen sketch. Okay, so now, oops, seems like it didn't do that. Let's try that again. Yes, all right, that's better. So now, what this says is that if you look at if you take the arithmetic mean of all these vertical line lengths here, okay, it'll be equal to this line length here, which is the mean value. Okay, as you see up here, as you see over here, 14.67 is the length of this ordinate minus the length of this ordinate divided by the interval width, which is 2. And that's how you can actually find the arithmetic mean of all the infinitely many y ordinates in the shaded region here. And what's interesting to note is that if you look at the original function f of x, the slope of this tangent line is always equal to the length of this y ordinate, okay? So it doesn't matter how you do this. Let's see if I can't grab it here, but I'll show you in a moment. So really what you've got here is you've got the mean value theorem, which states that f of c is equal to f of b minus f of a. Just get that right there, minus f of a over b minus a, right? This here is b and this is a. And this here is f of a. Let's change to a darker color. This here is f of a. I'm sorry, that's f dash of a and f dash of b, like so. So this here is equal to the length of this line and also the slope of the tangent line at this point, okay? And it's very easy to see how this line length is the arithmetic mean of all these infinitely many ordinates in this region. And I'm about to show you how. So on my website, on my Google Drive, you will find two proofs. One using your bogus calculus, okay, the machinery of your bogus calculus, which is this one, and the other one using the new calculus. And I will provide links to both in a moment. But what I was saying earlier on, it doesn't matter how you move that interval. Of course, it must either be all positive or all negative, because if you mix positive areas with negative areas, then it's meaningless nonsense. It's like that rut which you find mainstream lecturers teaching you called the net change theorem. It's bogus and it doesn't represent anything. Okay, so you cannot mix areas. And if you want to find the area, you'll have to find the arithmetic mean of all those vertical line lengths. You cannot mix this area with this area here, because that's not going to give you the right value. Before I came along, no one knew that there was a general formula for all areas. And that general formula states that an area is defined as the arithmetic mean of all the vertical line lengths in this shaded region multiplied by the interval width, which is incidentally also the arithmetic mean of all the horizontal line lengths. And how is that so? I'll show you in a moment. Well, if, for example, you've got a square there, so you basically a rectangle. I can't redo that. Yeah, I can redo that. So you've got a rectangle here. Let's just see if I can make that a straight line, something like that. And then this area here all becomes a rectangle, right? And so you also have the interval length here being the arithmetic mean of all the horizontal line lengths. Of course, it's not that high. It's actually down here, not up there. Okay, so this is a little applet which shows you, and also here's the tangent line. You can see the tangent line gradient is equal to the mean value, okay? And it doesn't matter where it is, all right? So that's pretty much it. This works for any function and every function, and it's the reason why calculus works, okay? The mean value theorem is the reason why calculus works. So I want you to know that when I first revealed this knowledge, and right up till now, it's still being ridiculed and rejected by mainstream academics. But if you learn the new calculus, you'll see that all these things I'm telling you here is true. And what they've taught you in mainstream calculus is really ill-formed and incorrect, even though the results are generally correct, or the theorem that comes out of a particular idea. So I hope you've enjoyed this little presentation. I've given many similar presentations to this, but I do it as a reminder because I think people need to be reminded. And so if you'd like this little presentation, vote it up and become a subscriber too. This is a new calculus channel. I'm John Gabriel. Till next time, goodbye.